Hey, well, greetings, Chem Department. We're going to look at a neutralization reaction. And the neutralization reaction, the idea is that if we have an acid and a base reacting together, they're going to produce a salt, which is a metal and a nonmetal, and water, H2O. So one of the things we're going to need is an indicator. Indicators are going to be something that changes colors depending on the pH. The indicator we're going to use today is going to be paper that actually will, depending on what color it changes, will actually show us the different level of pH that it has. So the molecule in there will change color depending on the environment it has. And so the reaction we're going to look at is a little bit more unusual one, but very popular. And the reaction we're going to be looking at today is our classic idea of taking baking soda and reacting it with vinegar. And so for that reaction, our first substance that we have, baking soda's chemical formula, sodium bicarbonate, NaHCO3, which is a solid, plus vinegar, acetic acid, the active ingredient vinegar, HC2H3O2, which is dissolved in water already, so it comes out as 5% solution aqueous there. And it's going to produce sodium carbonate, our metal and our non-metal part coming together, and then carbonic acid. But right away, carbonic acid breaks down into H2O and CO2, so we lose any of our acid or base that we originally had to begin with. So to kind of test these out pH-wise, we have some baking soda, but the problem is that baking soda is in the solid form right now. So to change that up a little bit, I've just got a little bit of distilled water. Just going to drop a little distilled water into there so that we can kind of make it into a solution. And then if we take that pH paper and we just bring it into a solution, we can start to see it turn color, and it kind of makes kind of a greenish color somewhere in that 8 to 9 range is where we're at. And at the same time, taking a little bit of the vinegar and dropping it on the pH paper. And this time we can see that we've got a much nicer red color, where we're somewhere in that pH of maybe 3, maybe 2, maybe somewhere in that area, relatively speaking. So what we have is we can see we have our acid and our base. Now, if we take those two, I've got some extra baking soda over here. If we were to take some vinegar and mix it with the baking soda, we can see not only a reaction start to occur, some fizzing and bubbling, but as we bring our pH paper in, we can see that it's a much lighter orange color now than it was before. And as it continues to react, we're actually going to get it back to a much closer to that 6 or 7 area pH-wise. So our pH indicator paper here, changing color depending on what state we are in, acidic or basic wise. So we're turning our colors from an acid to a base, and as that acid and base get combined together, they actually neutralize each other out. Now, kind of entertaining would be the fact that if we were to take some extra baking soda and extra vinegar and actually combine them together, we produce a little bit more gas. And if we produce some more gas, well, that pressure can build up. So I'm just going to take and see if this will work, make a little bit of a mess here. We'll get ready. All I'm going to do is just try to cover it with a balloon as we're going, but we'll see if we can actually collect some of that gas before it erupts over the top. And as it starts to produce some of that gas, we can hopefully see that balloon start to inflate as we're creating that gas. Now, the gas created more space or takes up more space than it did as the liquid or the solids that were in here. So as the gas takes up more space, that pressure can build up. If that pressure can build up, I bet we could use that for some other uses or more entertaining. So we'll check on that too. All right, Houston, we're preparing our rocket fuel. We've got our sodium bicarbonate, known as baking soda, and we've filled our rocket with vinegar, known as acetic acid. When we mix the two, hopefully we're going to produce some carbon dioxide, enough pressure to build up from that gas to ignite and shoot the rocket. So we'll carefully insert, and this will take anywhere, they say, between 10 and 30 seconds for it to launch. We'll get ready to mix. We have liftoff!
And landing.
Yeah!